Hi. So far, we have a ball in our physics world, and it falls down, but instead of bouncing off of the walls like it should, it just keeps on falling down forever because we don't have walls in our physics engine. And that's what we're going to add in today's video. So I can switch over to IntelliJ. What we want to first add before we make our box physical is a type for a line, because a box is just 4 lines. So I'm going to create a class line, which is going to take start location, or just start, of type point, end of type point, and a color of type string. This is going to extend sprite of that color. Now, the first thing I need to do is implement location. So I'm going to do def location. And it doesn't really matter here because I'm just going to be rendering it based on start and end. So I'm just going to put start. Now I'm going to override def render, which is going to take context of type canvas, rendering context 2D. This is going to return us unit. And now we can render. So first thing we need to do is super dot render with our context so that we set the colors. Now to render our line, we did this right at the beginning when we were first just toying around with our canvas. We do context dot begin path. We do context dot move to. So we move our pen over to our start point. Then we're going to do a line to our end point. And we're going to make a stroke. And that draws it. So now we have a type for line, and we can use this to render. But what we're more interested with this line is the ability to add it to our physics engine. So let's create a class physics line, which is going to take the same parameters here: a start, an end, a color. It's also going to take a val world, type world, and this is going to extend a sprite of that color. Or actually, we don't even need sprite. We need to extend a line from the start and end with the color. I'm going to move this to the next line. But it's going to be a line with physics. So by implementing that physics trait, we now do require ourselves to implement a few methods. So I'm going to add those. First thing we need to implement is the shape type. We don't need override here because it's not already implemented. The shape type, what we're going to do for a line is there's actually no body of type line in physics.js. But we can simulate the characteristics of a line by creating a really thin parallelogram. And in physics.js, we can do that with Convex Polygon. Now, when we're using a convex polygon, let's go ahead here and we can do geometry, convex polygon geometry. What we need to do is create our setup here. So I'm going to actually go over to physics and we're going to create a new type to handle this setup for a convex polygon. I'm just going to call this polygon because I don't have anything else. So Polygon Setup, and this is going to be Polygon Setup. And Polygon Setup doesn't have a radius, but it does have vertices. And this is going to be an array of vectors. So we're going to do, and this is a JavaScript array, not a Scala array. So we're going to do js.array of vector. And this is each of the vertices. Now, we're not going to take a radius here we're going to take vertices of type js.array of vector. And this is not going to return us a circle setup, it's going to return us a polygon setup. Now, instead of doing radius equals radius, we do vertices, and that's the name they use here, so we're good with that, is equal to vertices, and we're going to cast this to a polygon setup. But everything else is the same. We have initial x and y, which are going to set to the center of the line in our line sprite, initial velocity, and a treatment of does it move or not. Now we can go back here, and we need to implement it now. So I'm going to create a polygon setup. I can get rid of this type so we know what that type is. Our initial x and y are going to be calculated by knowing the center between start and end. So we're going to do start, parentheses, start.x plus end.x divided by 2. So that's the middle x value. And we're going to have start.y plus end.y divided by 2. And this gives us our middle y. So this is our middle point. Now we need our initial velocity x and y. We're not going to have an initial velocity. It's actually going to be a static. We're not going to have it move around because this needs to be fixed in place so that the ball bounces off. And the last thing we need is the vertices. So I'm going to create an array. And we're going to create a bunch of vectors. So the first vector is going to be our starting point. So I'm going to do start.x and start.y. And to create our parallelogram, all I'm going to do is take each of start and end and shift them down and decrease their x and decrease their y by 1 for each of these. And that gives us 2 new points for our parallelogram. So I'm going to have start x, start y. Then I'm going to move to start.x minus 1, start.y minus 1. Then I'm going to move to end x minus 1. So we start, shift down. Now we're going to end, and then we're going to end shifted down, and then we're going to go to end. So this is n minus 1, and y minus 1, and the last one is going to be our end point. And so now we've created an extremely thin parallelogram, which is going to be our vertices list. Now what's this error? We have a scala array of immutable vector. Okay, I think we might, we need to do physics vector. So I'm actually going to do js.array here. And this is should, okay, so for some reason we're not using a physics vector, we're using a scala vector. What we want to do instead is do physics js.vector. Oh, but what am I doing? We don't even have a way to create a vector. That's why Scala is not letting us do it. So I need to switch over to physics. So we've created a type for a vector, but we haven't yet created a way to make a new vector. So I can switch over to the documentation and let's go to vector. Where would a vector be? Here is a vector. Now if we want to create a vector, we have to do a new physics.vector with x and y. So what I'm going to do is I'm going to take this, so we can call physics.vector with x and y. So we can either use this as a constructor or as a function. So I'm actually going to use this as a function. So I'm going to do object vector extends js.object. So this is going to be a companion object for this. And this is going to have a JS name physics.vector. And it's going to take 2 numbers, x and y, for its coordinates. So I'm going to have a def apply. So this is going to create our vector. It's going to take x of type of double and y of type of double. It's going to return us a vector. And this is implemented in the library, so it's js.native. Now, if we go to our sprite, we can use this and be fine. And I think we can actually get rid of, no, we can't. So now we have a JavaScript array of the vectors that are forming our physics line. Now, we can implement our physical box. So I'm going to create a class physics box. It's going to take the same parameters. We don't have to do the underscore here. This is going to extend a box. I'm going to put this on the next line. And we just copy all these: location, width, height, and color. For physics box, we're actually not going to extend physics, because since physics box is just going to be composed of a bunch of lines, we're just going to create them inside and let the physics work happen within physics line. So what I'm going to do is I'm going to do val edges or corners. So first I'm going to calculate all of the corner points. So I'm going to create a list of point. So the first corner is going to be location, which is our top left. Then we're going to have the same y, but the x shifted over. So I'm going to do point location.x, and we're going to add the width of our box, but location.y is going to be the same. Then the third point is going to be our bottom right, which is going to have both location x plus width and location y plus height. Then we'll have on the left, but at the bottom, which isn't going to have width added to location.x, but it will have height added to location.y. And lastly, now we've gone all the way here, we need to return to our location. So this is kind of like how to draw your box. Now we're going to create val lines. What we want to do is we want to take each pair of adjacent corners and convert them into a physics line. So to do that, I'm going to do corners.sliding 2. So this will give me a sliding window of 2 at a time. I can convert this to a list, and I can map each array. So I get an array of 2 points, and I can create a physics line based on this. New physics line. My array's first element, my array's second element, given with index 1, and the color is going to be the color of my box. So, and one last thing we need is the world, which I also need to add here. I'm going to take world of type world. So now we've created all our physics lines. We have one thing to do. When we created the physics class, we did this lazy val body because we wanted to make sure this was called only after the entire sprite itself was constructed. But what we need to do here is make sure that body is initialized, because we're not going to be accessing it otherwise. We need to initialize it right here. And to do that, all I have to do is lines.forEach. I'm going to just do _.body. And this will cause this lazy val to be evaluated. So now we have a physics box implementation. I can go to Hello Collidium, and all I have to do is change our box to a physics box. Let's try. Okay, we have an error. We need to give our world here. But if we go here, we'll see that our ball is still falling through. Why is this happening? Let's take a look at the physics documentation to get a hint. So if I go into behavior and I look at the behaviors, we see that detecting body collisions and making that impulse response are all behaviors that we need to add so that it bounces. So the first one we want to add is body collision detection. So I'm going to just copy this, and we want to add body collision detection. The next one I want to add is impulse response, so body. So this will cause the actual bounce, impulse response. Then we also need the sweep prune behavior. So this will work, the code we have will work by itself, but it's going to be very slow. The sweep prune behavior causes the collision detection to use the sweep and prune implementation, which is a lot faster. So I'm going to add sweep prune, and now it should work. Okay, so looks like we detected it right there. We can see it kind of falling through. Let's try to figure out why it didn't bounce. So we're adding constant acceleration, body collision detection, and sweep prune. Let's see if there's anything else that we might have forgotten. Body collision detection, impulse response, sweep prune. We don't need to have edge collision detection. Oh, I totally forgot. I deleted this impulse response. I don't know. So what was happening was that we detected the collision. That's why it started kind of chunking, because it became kind of slow, since now the two physics elements were colliding with each other, but we weren't ever bouncing. So now I need to add this impulse response. And now we get our bounce. So now we have a bouncing ball in our physics world. Now, one thing we notice is the ball is rising quite high after each bounce. Let's make things a little more realistic by setting a restitution for our ball. So when you're creating a physics circle, one of the parameters you can give is a restitution, which is a double, which tells physics.js how much energy the ball should bounce back up with every time. And what I want to do here is I want to pass restitution equals restitution, and I want to add this as a parameter in circle setup, restitution. Now in Sprite, with my physics circle, first let's just set this to 1 to get the behavior we already had. Now if we compile, I can reload, and we get the same behavior. Now let's make it 0.5, so it only bounces up with half the energy. Now if I reload, now we'll see it's not bouncing as much, and it'll actually come to a rest pretty quickly. And later, when we're making our game even more fun, we'll probably tweak with this value to get the optimal fun but tricky value. But that's it for this video. In our next video, we'll start working with adding an interactive element to our game. I'll see you then.